All right, great. Thank you very much. So yes, I'm audible now. So friends, sorry for a small technical glitch from my side. So welcome back once again on the YouTube channel of BYJU'S Exam Prep. I'll quickly repeat whatever I've told you just now. Obviously, I was not audible for the first few minutes of this session. So now I'm clearly audible. And yes, we have our SNAP examination day after tomorrow. And all of you must be well prepared for this examination. So I'm here once again in front of you with yet another session for the revision of all of you. All right. So in this session, obviously, I'm not expecting to teach you anything. I'm just here so that you will have warmed up yourself for this particular examination, just looking at the last set of concepts, last set of questions, just as a revision session. Right. So okay, so you're asking Hardik sectional cutoff for QA in SNAP. Hardik, there are no sectional cutoff of any sections as far as SNAP examination is concerned. So for all the colleges of SNAP, you just need to clear the overall cutoff. Okay, so as such, there is no sectional cutoff, right? Okay, so friends, let's begin this session. So first of all, understanding the relevance of this examination, this section. So this particular area called number system, we can expect at most like one or two questions in IFT. So from IFT's point of view, probably direct questions of number systems may not come. Listen carefully to whatever I'm saying. From IFT's point of view, I can say that direct questions of number systems may not come, but definitely there will always be an indirect usage of number systems in all these examinations. Same is the case with IFT. So direct questions zaruri nahi aayenge, but the applications of number systems in the other questions in data interpretation, yes, it will always be tested. It will remain there. Talking about SNAP, you can expect 10 to 20% of the questions of QA comprising of number system. So we have seen like 2 or 3 questions to aa hi jate hain yahan se, right? You can expect 4 questions as well out of the 20 questions in the QA section. So let's have a look at the trends over the last 4 years for IFT examination. So in IFT 2018, 2020, 2021, one direct question has been asked out of number systems, and there was no direct question from number systems in 2019. I'm talking about direct questions. I'm not talking about the applications, because applications of number system will be there in almost every question, right? Okay. Right. So Harit is asking, so would you be taking last lap to modern maths? Harit, probably I'll not be taking before SNAP examination, this examination, maybe some other faculty. So, but I'll have a look at it, and we'll definitely post this information. So it is safe to give one mock in these last 2 days to check the strategy and accuracy. Varun, I believe that if you want to form a strategy, if you would have wanted to check the strategy, then you would have done it by now. It is not at all advisable to take mock SNAP just one day before SNAP examination. If in case your examination ends up with less number of marks, then it will be a huge amount of demotivation for you. So in the last 2 days, no sectional any mock test is not suggested. Sir, is SIBM Nagpur good for ABM? Yes. Divya, SIBM Nagpur is good, but abhi call leke aao, call convert karo, and then you might compare SIBM Nagpur with other colleges which offers agribusiness management. Guys, please, at this point in time, don't ask these questions. Let us finish this session, and then I'll spare out last 5 to 10 minutes for all of you for this general questions. Okay. Now, moving forward, looking at the trend over the last 2 years in all the 3 slots of CAT 2020, of SNAP 2020 and SNAP 2021. So, in SNAP 2020, we have seen 2 questions in each of the sets, in each of the slots for SNAP. In SNAP 2021, there were 3 questions in each of the slots out of 20 questions. So yes, properly balanced both the years. And this year, yes, you can expect anywhere from 2 to 4 direct questions from the topics of number system. All right. Now, Anvesh, you're asking 40 to 45. Yes, it is wonderful. Try to increase it to 45 plus, and you will definitely get a call from all the best colleges under SNAP. Okay. All right, so continue करते हैं session. So talking about the topics under number system, so classification of numbers, divisibility rules, factors, multiples, LCM HCF, their properties of LCM HCF, greatest integer power and the number of zeros, cyclicity, repetition of the unit digit in any power, all right, and last two digits and the remainder theorems. So these are some of the important, some of the total areas under number system. You might not find the question from each and every topic in SNAP. Like if I talk about remainders, then you will see less number of questions from remainder theorems and you will see more number of questions on the other areas. Similarly, last two digits पे भी ज़्यादातर question नहीं देखा गया है SNAP में, right? But don't generalize whatever I'm saying. ऐसा नहीं है कि अभी तक नहीं आया तो आगे भी नहीं आएगा, ऐसा जरूरी नहीं है. So you may find question on any of these areas under the number system. All right? Yes, Hardik, you are absolutely correct. So Kushal, practice से ही speed improve होगी. There is no shortcut to improve your speed. So जितने ज़्यादा questions practice करोगे उतनी ज़्यादा speed increase हो जाएगी. 43 to 47 marks in mocks. What is the minimum score in SNAP examination? What can be the minimum? Yash, how can I tell you, yaar, matlab you are scoring 43 to 47. How can I tell you your minimum score? So if you are scoring consistently in the range of 43 to 47, then yes, there are higher chances of you scoring the same range of marks in the actual SNAP examination. All right. Okay. Now, moving ahead, talking about some of the important rules, important formulas under number system. So first of all, if I'll talk about the classification of number system, then the most important thing is prime numbers. Now, prime numbers which have exactly two factors or exactly two divisors are called prime numbers. Make sure that you remember these 25 numbers, 25 prime numbers in the first 100 natural numbers. So in the first 100 natural numbers, these are the 25 prime numbers. You must remember each and every number in this set. Also, if I want to generalize the way prime numbers can be expressed, then I can say that after 3 or above 3, every prime number can be expressed as 1 less than a multiple of 6 and or 1 more than a multiple of 6. So every prime number above 3 can be expressed either in the form of 6x plus 1 or 6x minus 1, right? So you pick any prime number and it will go up till infinity. Not only true for the first 100 natural numbers, prime numbers under first 100 natural numbers, but it is true for every prime number which is more than 3, right? So if I'll pick up any prime number, let's say 89, so I can express this prime number as either a multiple of 6 plus 1 or a multiple of 6 minus 1. So I can write 89 as 6 into 15 minus 1. So multiple of 6, that is 90 minus 1. So 89 can be expressed like this. So likewise, every prime number can be expressed in the form of 6x plus 1 or 6x minus 1. Okay. Devu, SIIB is a good college. Guys, एक चीज understand करो, मैंने ये पहले भी repeat किया है, every college is good. हर एक कॉलेज अच्छा होता है. It depends on student to student whether you want to apply to that college or not. Since guys, I don't know about your credentials, I don't know about your education background, I don't know about your ambition, then like in this short span of time, without knowing anything about you, I cannot suggest anything. Also, you should not be asking such questions to anyone who don't know about you. Okay, so make sure that you have a mentor, you have a teacher who know everything about you, who know everything about your performance of the mock papers. Then only that person is like will be able to suggest you rightly about which forms, which colleges needs to be applied. ठीक है, तो ये चीज ध्यान रखो. ओके, चलो आगे चलते हैं. Next set of important formulas are some divisibility rules. So 2 ka divisibility rule and the powers of 2. So 2, 4, 8, 16, 32 and so on. If I look at the powers of 2, then let's say 8. So 8 can be written as 2 raised to the power 3. So the divisibility rule of 8 will be the number formed by the last 3 digits. The number formed by the last 3 digits should be divisible by 8. Similarly, for any number to be divisible by 2 raised to the power n, the number formed by the last n digits should be divisible by 2 raised to the power n. Alright, now the similar divisibility rule is applicable for 5 and the powers of 5. So for any number to be divisible by 5 raised to the power n, the number formed by the last n digits of the number should be completely divisible by 5 raised to the power n. Right? Straightforward, simple rules हैं. तो अगर मेरे को 625 का चेक करना है divisibility rule, so 625 can be written as 5 raised to the power 4. So whatever the number is given to you, pick up the last 4 digits of that number. So the number formed by the last 4 digits of this number should be divisible by 625. Alright, okay? So this is rule for the powers of 5. Now next is rule for 3 as well as 9. Only these two numbers. So 3 और 9 का बहुत simple rule होता है. The number जो भी given है number, उसमें digits अलग अलग करो and उनका sum of digits calculate कर लो. So if the sum of the digits of the number of the entire number is completely divisible by 3, then the original number will be completely divisible by 3. Similar is the case for 9. If sum of the digits is completely divisible by 9, then the entire number, the original number, will also be completely divisible by 9. Alright, so this is the rule for 3 and 9. Now finally the rule for 11. The rule for 11 is जितने भी numbers, digits हैं even places पे, उनको add करो. जितने भी remaining numbers हैं odd places पे, उनको add करो. So take the sum of all the digits occurring at even places and then take the sum of all the digits occurring at odd places. Now find out the difference of these two sums which are obtained. If that difference is completely divisible by 11, then the original number will also be completely divisible by 11. Alright, so these are certain basic rules, fundamental rules that you must remember about the divisibility. Alright, now next very important rule that is used for divisibility, और इस type के questions बहुत आते हैं. SNAP में मिल जाएगा, IFT में मिल जाएगा, नारसी मुंजी, ZAT. So you will find this particular property at a lot of places. The divisibility rule of number which is written in the form of a raised to the power n plus b raised to the power n, or written in the form of a raised to the power n minus b raised to the power n. So quickly take out pen and paper and note down these rules if you don't know about them already. Okay? So a raised to the power n plus b raised to the power n. First of all, let's talk about this. Now, the divisibility will depend on the value of n. और value नहीं बोलूंगा मैं, nature बोलूंगा. If n is even or n is odd. So if n is even, then it will not be divisible by a plus b. इससे भी divisible नहीं होगा, a minus b से भी divisible नहीं होगा. So we are just looking at if these numbers will they be divisible by a plus b or a minus b. So if the value of n is even, it will not be divisible by any two of them, right? If the value of n is odd, as in अगर मैं बोलता हूं a cube plus b cube or a raised to the power 9 plus b raised to the power 9, then this type of number will always be divisible by a plus b. Alright, a plus b से हमेशा divisible होगा, right? Okay, yes Kshitij, I'll definitely give examples. So Kshitij, if I look at any number of this form, let's say 11 raised to the power 5 plus 26 raised to the power 5. I'm sorry, 26 raised to the power 5. Okay, so 11 raised to the power 5 plus 26 raised to the power 5. Now here I can see that this number is in the form of a raised to the power n plus b raised to the power n, and the value of n is odd. So this number will always be divisible by 11 plus 26, that is 37. So any number like this will be divisible by 37. So this is the first example. Okay, okay. Now let's move towards the next one, a raised to the power n minus b raised to the power n when n is odd. So let's say 23 raised to the power 31 minus 5 raised to the power 31. 23 raised to the power 31 minus 5 raised to the power 31. So this is of the form a raised to the power n minus b raised to the power n, and the value of n is odd. So this number will always be divisible by 23 minus 5, right? 23 minus 5 कितना होता है 18. So this number will always be divisible by 18. Correct? Now the last example, if the value of n is even in this case. So 23 raised to the power 6 minus 5 raised to the power 6. The power is even. So this number will be divisible by 23 minus 5 as well as 23 plus 5. Alright, that means 18 and 28 in दोनों numbers से divisible होगा. Okay, right? So please note down these rules and like definitely question आता है इसमें से, बहुत important area है. Okay, now let's move ahead and look at the next thing, the factors. Now how to calculate number of factors of any given number? Basic rule है, simple rule है, सबने पढ़ा होगा. I'm just revising this. So first of all, do the prime factorization of the number. So write number as the product of prime factors. So prime number 1 raised to the power a multiply by prime number, second prime number raised to the power b, multiply third prime number raised to the power c, and so on. So first of all, prime factorization needs to be done. Then to calculate the number of factors, just consider the powers of these numbers and add 1 to each and every power. So a plus 1, b plus 1, c plus 1, and so on, and multiply all of them. Okay, so just consider the powers, add 1 to each power and multiply all of them, and this is how you can obtain the number of factors of any given number. Okay, Ankita probably would have asked something. Thank you, Rahul, to answer that. Sir, we have to apply for SIBM individually also. Yes, you have to apply for each and every college individually under SNAP. Okay, चलिए आगे चलते हैं. This was calculating number of factors. Now the formula for number as a product of two co-prime factors. So if any number is given to you and you want to express it as the product of two co-prime factors. For example, let's say 20. I can write 20 as 2 into 10. I can write 20 as 1 into 20. I can write 20 as 4 into 5. Okay. But out of these ways, I just need only those ways such that the numbers are co-prime with respect to each other. So I can say that 1 and 20, they are co-prime to each other. 2 and 10, they are not co-prime with respect to each other. 4 and 5 are co-prime with respect to each other. Okay, so if the question is asked, what is the number of ways of writing 20 as the product of two co-prime factors? The number of ways will be 2, 1 and 2. Alright, so for 20 the answer is 2. So how we can calculate it using the direct formula? So the formula is 2 raised to the power n minus 1. 2 raised to the power n minus 1, where n is the number of prime factors of the number. So for 20 को मैं लिख सकता हूँ 2 raised to the power 2 into 5 raised to the power 1. Okay, so this is how I can express 20 as prime factorization. अब 20 के prime factors कौन कौन से हैं? 2 is one of the prime factors of 20. 5 is another prime factor of 20. So 20 has two prime factors. So small n का value 2 हो जाएगा. Right? Formula में apply करो 2 raised to the power small n, that is 2 minus 1, that is 2 raised to the power 1. Answer is 2. So 20 के लिए मैंने 2 ways निकाले थे, 1 and 2, and you can get it from the formula. Okay, right Varun, you were absolutely correct. Good. Okay, so this is how you can calculate in how many ways I can write a number as the product of two co-prime factors. ठीक है, आगे चलते हैं. Next is LCM HCF, some of the very important properties of LCM HCF. You would already know how to find out LCM HCF. One of the very important properties that is used probably in most of the questions of LCM HCF is product of LCM and HCF of any two numbers is equal to the product of these numbers. Now this property is applicable only when there are two numbers. We are calculating the LCM HCF of two numbers, then only you can use this property. You cannot apply this property for more than two numbers. हमेशा true नहीं होगी, कभी true होगी, कभी true नहीं होगी. Okay, so for two numbers, Product of their LCM and HCF will always be equal to the product of the numbers, right? Okay. Next, some properties of HCF and LCM. HCF of two co-prime numbers. कोई भी दो co-prime numbers हैं. I'll take an example, 21 and 25. These two numbers are co-prime. Now, co-prime numbers वही होते हैं which don't have any common factor except one. मतलब the highest common factor of such numbers is 1. So for any two co-prime numbers, HCF is always 1 and the LCM is always the product of the numbers, 21 into 25, right? So this is one another property. Next property, HCF is always the factor of the difference of two numbers. Okay, so HCF इन दोनों numbers का factor होगा हमेशा. As in, if I take, let's say, another numbers, 80 and 90. So 80 और 90 का difference क्या है? 80 और 90 का difference 10 है, तो HCF 10 का कोई ना कोई factor होगा. 10 का factor 10 होता है, तो HCF will be 10 in this case. So HCF will always be the factor of the difference of the two numbers जिनका हम HCF calculate कर रहे हैं, right? स्नैप के लिए इतनी ज्यादा इंपॉर्टेंट नहीं है प्रॉपर्टी, बट आईएफटी में ये प्रॉपर्टी काम आ सकती है. ओके, नेक्स्ट, एलसीएम ऑफ अ सेट ऑफ नंबर्स इज ऑलवेज अ मल्टीपल ऑफ एचसीएफ. एलसीएम एचसीएफ का मल्टीपल हमेशा होगा. द अदर वे अराउंड, एचसीएफ हाईएस्ट कॉमन फैक्टर विल ऑलवेज बी अ फैक्टर ऑफ एलसीएम. ओके, यस पुनीत, I'll go back. विवेक, प्लीज वेट. सो लेट मी फिनिश दिस. अब मैं इसके बाद प्रीवियस स्लाइड पे जाता हूं, ठीक है? डोंट वरी. Okay, so let's repeat. So some of the students have requested कि ये जो co-prime factors है इसको मैं repeat कर दूं. So I'll do it taking an example. ठीक है? So let's say question is, in how many ways 180 can be expressed as the product of two co-prime factors. ठीक है? So first of all, let's do the prime factorization of 180, right? So 180 can be written as 92 raised to the power 2 into 3 square into 5 raised to the power 1. So this is how I can write 180. Now check how many prime factors 180 has. So 180 ka 1, 2 and 3. There are 3 prime factors for 180. Alright. So in the formula, the value of small n will be equal to 3. So the number of ways in which 180 can be written as the product of two co-prime factors will be 2 raised to the power n minus 1. This is the formula. You can substitute the value 2 raised to the power 3 minus 1. That is 2 raised to the power 2, 4. So there will be 4 ways in which 180 can be expressed as the product of two co-prime factors. ठीक है? I hope Puneet and Vivek, I am clear with this. Right? चलिए आगे चलते हैं. So this we have already done. Now another few properties of LCM HCF. So while you are calculating the HCF or LCM of fractions, ठीक है? So HCF of fractions will be HCF of numerators divided by LCM of denominators, and next LCM of fractions will be reverse of this, LCM of numerators divided by HCF of denominators. Right? Now, while calculating HCF and LCM of fractions, you must take care of one very important thing, जो हम भूल जाते हैं बहुत बार. All the fractions should be converted in their lowest forms. ठीक है? Simplest form, lowest form, simplest form में convert करना है. So अगर आपके पास कोई fraction है, let's say 9 by 33. So convert the common factor, cancel out the common factors. इसको simplest form में convert करो, 3 upon 11, and then apply these formulas. Okay? All right? Visham, you have asked if the co-prime अगर ordered pairs calculate करने हैं तो answer double हो जाएगा. Absolutely correct, Mandeep. So if we are talking about the ordered pairs such that the order will matter, then answer double हो जाएगा. Simple, you know that. ठीक है? So Sham, I have given you the unordered pairs. If you are asked ordered pairs, then it will be doubled. Okay, all right, chaliye. Now let us practice some questions, all of you. So all of you, pull up your socks. Now it will be a rapid fire round of next half an hour. And in this half an hour, let's see how many of you will answer how many of the questions correctly. Okay? So start karte hain. But before that, I would request all of you, जो मैं हर बार करता ही हूँ request, please, before we enter into the questions, do like this session. जल्दी से like button दबा दो, and so that we can enter into these questions, and we'll be solving these questions the way we solve every day. So I'll be putting up one question on your screen, and I'll wait for a few seconds. We'll ask you to write your answers, and all right, so Mandeep, ready, steady, po. So first question on your screen now. The product of two-digit numbers is 1938 if the product of the units digit is 28 and the product of their tens digit is 15. Then what is the units digit of their sum? Quickly. You have less than 30 seconds for this question. Come on, I need an answer as soon as possible. All right, Varun, first one to answer. Let's see if this answer is correct or not. Mandeep says option A, Kush option B, Mansa says option A. Lots of different answers I'm getting. Okay, nice. Okay, now this is not, I'll not call it not a difficult question, but I'll say that this is easiest question that you will get in the examination. ठीक है, चलो analysis करते हैं. The product of two-digit numbers is 1938. The product of their units digit is 28, right? So let's say the numbers are A, B and C, D, such that the product of their units digit is 28. B multiplied D is 28. तो व्हाट कैन बी द पॉसिबिलिटीज फॉर बी एंड डी? बी और डी की पॉसिबिलिटी क्या हो सकती है? मनदीप, मजे की बात यह है कि इस क्वेश्चन को कंप्लीट करने की जरूरत ही नहीं है. You don't have to calculate the values of A, B, C, D, all of them. So give me the value of B and D if their product is 28. Now B and D obviously are single digit numbers because they are the digits at units place. So B and D की possibility एक ही हो सकती है, 4 into 7 या फिर 7 into 4. So one of them is 7 and the other one is 4. There is no other possibility for B and D, right? So B or D, 4 or 7 interchangeably, right? I need what is the unit digit of their sum. Now B is 4, D is 7 or vice versa. Whatever these numbers are, their sum will have a unit digit of 1. That's all, right? Question is over. No need to calculate the values of A and C. Okay. So the product of tens digit is given, the product of the numbers is given. All this is redundant information. Why they put this information? Because some of the students might end up wasting time on this. You don't have to do that. You can still give the answer as option A, which is 1. All right. So the correct answer, yes, definitely it is 1. Okay. चलिए आगे चलते हैं. सिंपल क्वेश्चन था, जस्ट अ वार्म अप क्वेश्चन. नेक्स्ट क्वेश्चन ऑन योर स्क्रीन. What least number should be multiplied with 1875 so that it becomes a perfect square? Again, an easy question. So answer jaldi se jaldi aa jana chahiye. What least number should be multiplied with 1875 so that it becomes a perfect square? All right, good. All right, take an answer from all of you. Now, method is simple. We'll do the prime factorization and we'll see if the number is perfect square or not, or like all the powers are even or not. So 1875, I can divide it by 25 directly. 25 into 7, 175 and 5, and then again 25 and then 3. So this number can be written as 5 raised to the power 4 multiplied by 3 raised to the power 1. Now this portion is already a perfect square. To make this portion a perfect square, I have to multiply it with 3. Okay, so the least number which should be multiplied with this number to make it a perfect square is 3. And all of you are absolutely correct. Some of you have given a different answer. I hope you have understood why 3 will be the answer, why not or any other number is not the answer. Okay? So correct answer here is option C, that is 3. Question number 3. Two numbers A and B are such that their HCF is 33 and their sum is 528. Two numbers A and B are such that their HCF is 33 and the sum of A and B is 528. How many such pairs of A and B are possible? Now this is slightly tricky question. So those who understand the complete, all the concepts of number system, all the properties of LCM, HCF, those who have practiced some good number of questions of HCF, LCM, they will be easily able to do this question. Okay, Varun says A. Varun, यार दो आंसर देते हो तुम हमेशा. So in one go, try to give a correct answer. So Varun, option C, Rahul, option C, Yash, option C, Vishal, option D. Okay. All right, I'll wait for a few more seconds before I start with the explanation. Okay, now let's start with the explanation. Now all of you need to listen very carefully. Okay, now there are two numbers A and B such that their HCF is 33. Now the numbers HCF, highest common factor, is 33. So 33 is the factor of both these numbers. So both these numbers should be multiples of 33. So I can write these numbers as 33x and 33y. Okay, both the numbers will be multiples of 33. So the numbers are assumed as 33x and 33y. Now since 33 is their highest common factor, so other than 33 there should not be any common factor. That means both x and y will be co-prime with respect to each other. Both x and y will be co-prime with respect to each other, right? Now I'll use the sum. The sum of A and B is 528. That means 33x plus 33y is equal to 528. All right. So from here I'll get the value of x plus y. 528 divided by 33. So that is 1. 33, 198, 6. So 16 is the sum of x and y. Right? Now 16 is the sum of x and y. And we know that x and y are co-prime with respect to each other. Okay, so in how many ways I can express 16 as the sum of two co-prime numbers? a little bit of hidden trial. 1 plus 15, then 2 and 14 दोनों even numbers कभी नहीं होंगे. So even numbers हमेशा छोड़ सकते हो आप. So अगर मैं 2 कंसिडर करता हूं तो उसके साथ 14 आएगा. 2 and 14 are not co-prime. 3 and 13, 5 and 11, 7 and 9. Now 1, 2, 3, 4. Now these are unordered pairs. Now we are given the numbers as A and B. So these numbers can interchange their values. So 15 plus 1, 13 plus 3, 11 plus 5 and 9 plus 7. These can also be the respective values of X and Y. Now we have 8 possibilities for the values of X and Y. Right? Similarly, by substituting the values of X and Y here in A and B, we will get 8 different pairs for A and B. So the correct answer should be 8, not 4. Okay? So this is the trick for this question. A and B mentioned here. So that is why they are looking at the ordered pairs, not the unordered pairs. So right answer for this question will be option C, that is 8. Okay? All right, so that was question number 3. Let's move on to question number 4. How many two-digit numbers have exactly 3 factors? Now, an easy but logical question. How many two-digit numbers have exactly 3 factors? अब two-digit numbers start होते हैं 10 से up till 99. 10 से लेके 99 तक अब obviously I cannot check each and every number. It will take some time. So we'll go conceptually. So concept पता होना चाहिए. How many two-digit numbers have exactly 3 factors? I'll give you a minute for this. Now Devu, how do we know ordered pairs is asked? So Devu, in previous question, देखो मैं एक difference बताता हूँ. In the previous question, you are given A and B as the numbers. So मैं बोल रहा हूँ अगर A का value 5 है, B का value 6 है, तो opposite भी हो सकता है ना, A is 6 and B is 5. Okay, so whenever A and B, these variables are mentioned, then you will be taking ordered pairs. When do we have to take unordered pairs? So language क्या होगा? Two numbers are such that their HCF is 33 and the sum is 528. How many such pairs are possible? So if this is the language of the question, मैंने A और B mention नहीं किया. So if this is the language of the question, then you will have to take unordered pairs. In that scenario, answer will be 4. I hope Devu, I am clear. Okay? चलते हैं. Question number 4. How many two-digit numbers have exactly 3 factors? Any answer for this? How many two-digit numbers have exactly 3 factors? Now, number of factors, how to calculate it? I have already given you a formula a few minutes back in this session only. Okay. Now, I want 3 factors. Number of factors should be 3. So, the number should be of the form of prime number raised to the power 2. If any number is in this form, the square of a prime number, then the number of factors will be equal to 3. Okay, so I'll just check the square of some prime numbers. So 2 square is 4. It is not a 2-digit number. 3 square is 9, not a 2-digit number. 5 square is 25, is a 2-digit number. 7 square is 49, yes. 11 square is 121, not a 2-digit number. So that's it. These two numbers, 5 square, that is 25, and 49, will be the only 2-digit numbers which will have exactly 3 factors. All right. Absolutely. So a lot of you have already given the numbers. Wonderful to see that. Unman, good evening, sir, and people here. Your views on just released data saying 91 score is I'm sorry, Unmanned. I cannot tell you about the views. I cannot share my views because we have already conducted plenty of sessions in which we have told what will be the percentile you can score at any particular score. Okay, so not right now, not the portal here to discuss these things. Okay, so अभी हम snap के बारे में बात करेंगे and will restrict ourselves to that only. ठीक है, Jatin, number should be of the form the square of a prime number. I have mentioned it, the formula for calculating the number of factors at the beginning of this session. ठीक है? So prime number का square check करो. कौन से prime number का square 2-digit number होता है? So these are the only two prime numbers whose square is a 2-digit number. So that is why I have selected these two numbers. ठीक है? So the correct answer here is option B, that is 2. Question number 5. Find the digit at the units place of 1 factorial plus 2 factorial plus 3 factorial up till 100 factorial whole raised to the power 2. Gaurav, I absolutely agree with you. Different people have different set of mind, different point of view. So obviously cat is over now. We know our approximate score. We can find out the approximate percentile using that, and based on that you can fill up the forms. Okay. So nobody can guarantee any percentile to you. ठीक है, सबकी projections होती हैं. So let's not talk about that. All right, 9 is one of the answers, 6 is another, and 3. So 6, 3, or 9. These are the three answers that I'm getting. People, please don't forget about this square. So we have whole square of this. This is clearly mentioned here. Okay. Yes, yes, yes. So unmanned, this is what I'm asking. So obviously I cannot also be sure about what percentile that we are getting. So I cannot, I'm not a right person to comment on the views of other people. Okay, so this is what I mentioned. Right, so let's have a look at this one. Now 1 factorial is equal to 1, 2 factorial is equal to 2, 3 factorial is 6, 4 factorial is 24, 5 factorial will be 120. Now 5 factorial onward, the unit digit will always be 0, right? 5 factorial onward, if you look at the factorial of any number, the unit digit will be 0. Okay, so first of all, to determine the unit digit of this expression inside the bracket, I just add these four numbers, that's it. Okay, because from 5 factorial onwards, सबका unit digit 0 होगा. So there is no need to consider all the terms beyond or starting from 5 factorial. So the unit digit of the term inside the bracket will be 1 plus 2 plus 6 plus 4. So unit digit will be 3. Now you need to find the square of this. So if a number is ending with 3, the square of that number will end with 9. That is 3 square. Okay. So 3 square, that is 9. 9 will be the unit digit, and that should be the correct answer for this question. All right. Okay. Now next question. Question number 6. Yes, Mandeep. Square bhi tha yaar. All right. Now, what is the remainder when 9 raised to the power 60 is divided by 17? 9 raised to the power 60 when divided by 17. Any answer for this? Right, good. Lovely. 1. Most of you are saying 1. Some of you are saying, sir, can we expect any of these questions on Snap? Divya, not exactly questions यार, but इस type के जो questions कर रहे हैं हम वो conceptually Snap में आ सकते हैं. So this is the only agenda of taking on these questions in these sessions. So exact questions नहीं, but definitely like the concepts that we are doing, from these concepts the questions may be asked. Zelbe, no, I'm not from Gujarat. Why are you asking? So I'm not from Gujarat, I'm from Delhi. Okay, so 16 and 1, these are the two most common answers. So let's simplify this, let's calculate this. Now 9 raised to the power 60, first of all I'll convert it in the power of 3. So 3 raised to the power 120. Now I have to divide it by 17. So I'll have to divide it by 17. ठीक है? So 17 से divide करने के लिए मैं Euler's theorem use करूंगा. Okay, Euler's theorem says that denominator में क्या है? Prime number. So its Euler's number will be 16. So from the power, I'll remove the multiple of 16. So Euler number of 17 is equal to 16. Okay. So from the power, I will remove the highest multiple of 16. Highest multiple of 16 क्या है? यहाँ पे 120 से छोटा, 120 से छोटा highest multiple of 16 is 112. So from the power, I will remove 112. So the power will remain 8. And now I can divide 3 raised to the power 8 by 17. अब इसको करने के बहुत सारे तरीके हैं. Now 3 raised to the power 8 को I can write 3 raised to the power 4 into 3 raised to the power 4. Okay, 3 raised to the power 4 is 81 multiplied by 81 divided by 17. Now 81 when divided by 17, the remainder will be minus 4 in each case. Minus 4 into minus 4. The answer will be 16. So 16 is the correct answer. नहीं गौरव, 3 का पावर बिल्कुल लेना जरूरी नहीं है. Okay, and the base also not necessarily should be a prime number to apply Euler's theorem. Now I'll quickly give you the statement of Euler's theorem after this. So statement of Euler's theorem is a raised to the power n, और n की जगह मैं phi of n लिख देता हूं. So a को अगर मुझे let's say n से divide करना है and the power of a is Euler's number of n or any multiple of that, then the remainder will be 1. So I can remove the highest power from the highest multiple of the Euler's number of n from the power. There is a restriction that a and n should be co-prime with respect to each other. So this is the complete statement of Euler's theorem. Okay, all right. Okay, Ashu, हाँ, Jatin is absolutely right. So परसों examination है. Now tomorrow you need to keep your schedule light. ज्यादा स्टडीज नहीं करनी है, otherwise टेंशन होगी and day after tomorrow you'll not be able to perform good. So you need to chill, relax, like Jatin mentioned. Okay, and what you can do is maximum you can read some passages for 15-20 minutes, half an hour maximum, and just look at some of the formulas from the formula copy that you would have made for yourself. So maximum 2 or 3 hours study karo and just relax the entire day, and download your admit card, read the instructions carefully, locate your center, just take care of all these things tomorrow. Okay, chaliye. Next, Rohit, I have just mentioned. Okay, chaliye. Now next question is, how many natural numbers less than 500 are divisible by at least one of the numbers 2 or 3? Now be careful in answering this question. How many natural numbers less than 500 are divisible by at least one of the numbers 2 or 3? A very simple, straightforward question, but you need to be very careful in answering this. Manansha, yes, there are other methods, but the other methods will be very lengthy. Okay, so that is why I have not taken any other method. Manan, I'm really sorry यार, अभी Euler's theorem मैंने explain किया है just, but you can watch my other videos where I have explained Euler's theorem. Not right now, not here today. ठीक है? Towards the end of the session, I can give you one more example of how to apply Euler's theorem. ठीक है? So Manan, please wait for 10 minutes, and towards the end of the session, I'll definitely explain you Euler's theorem with an example. Probably it will help you day after tomorrow. All right. Now let's have a look at this question. Now the question is important from this point of view. How many natural numbers less than 500? So you have to consider less than 500. 500 consider nahi karna hai. Okay. Now the question is simple. Now multiples of 2. How many multiples of 2 will be there up till 499? 499 तक 2 के कितने multiples होंगे? Right? This is what you have to find out. So can you please write it? Up till 499, how many multiples of 2 will be there? So number of multiples of 2 will be 249. Then multiples of 3 kitne honge? It will be 166. Now the numbers which are multiples of 2 and 3, that means the multiples of 6 will be 83 up till 499. Okay? So the numbers which are divisible by 2 or 3, I'll be using the formula A union B, that is A plus B minus A intersection B. So that is 249, this number, plus 166 minus 83. And you can find the answer. So the final answer will be 332, and most of you have given a correct answer. That is lovely. Good. So that was question number 7. 332 is the answer. Quickly, let's move on to the next one, question number 8. Now, wonderful question this is. Let's see कौन सबसे पहले answer करता है. A is the sum of all even numbers from 1 to 50, and B is the sum of all odd numbers from 51 to 100. Find the value of modulus of A minus B. So basically, you'll have to find out the difference of A and B. No, Sadanan, like it doesn't make any difference. So one slot choose karo, two slot choose karo, three slot choose karo. It is that you should be able to give your best shot in whatever slot you have selected. No problem, Mandeep. It's just that mock में ना tension थोड़ी सी ज़्यादा होती है. Mock में actual exam में tension ज़्यादा होती है. So please leave your tension outside the examination hall, and I wish that examination में इस type की mistakes will not be repeated by you. Okay, so A is the sum of all even numbers from 1 to 50, and B is the sum of all odd numbers from 51 to 100. What is the value of modulus of A minus B? Now this question can be solved in less than 30 seconds. Simple सा logic, सीधा सीधा mind में आ जाना चाहिए. Now the value of A I'm writing as all even numbers. So 2 plus 4 plus 6 plus 8 and so on up till 50. So this will be the value of A. Now have a look at it. Zenul ने answer दिया. Zenul is the first one to give the answer. Good Zenul. Bhavin, Manasa, okay, सब same answer दे रहे हैं अब. Good. Now value of B, let's see how many of you have used the method that I am using. Value of B is sum of odd numbers from 51 up till 100. So 51, 53, 55, 57, मैं लिख रहा हूं बट इतना सब लिखने की, इतने सारे नंबर्स लिखने की जरूरत नहीं है, and 99. Okay, now just look at the difference of these two numbers. Difference of these two numbers is 49. Again, difference of these two numbers is 49. Difference of these two numbers is 49. Everywhere the difference is 49. So we will be adding 49. Okay. And how many times? How many terms will be there? 25 terms will be there. So final answer will be 49 into 25. That's it. 49 into 25, that is 1225 will be your answer, and it is option B. So quickly write yes if you have used the same method. I have not calculated the net value of A and B. No, I have not done that. Okay, so I have used this logic. So I have written all these things to explain you. You could have done it without writing so much of rough work. Yes, Sadanand, SNAP is generally like most number of questions are short, are not lengthy, and there are plenty of questions which will be direct formula based. ओके, सो किसी ने भी ये मेथड यूज नहीं किया या फिर किसी ने किया है ये मेथड यूज? चलिए आगे चलते हैं. Bhavin has used this method. So the correct answer here is 1225. Let's move towards question number 9. Find the greatest integral power of 6 in 100 factorial. All right, Mandeep. Good. Yes, Manan, it can be solved using formula, sum of even numbers. Yes, AP से use कर सकते हैं. But the method that I have taken, I believe that will be the quickest way of solving this. Find the greatest integral power of 6 in 100 factorial. Now it's my request to all those students who are watching in this session, if they haven't, please do like this session. So up till now, if you have not liked this session, please take a few seconds out and you just need to press the like button. Subscribe our channel so that you will not miss any further sessions that will conduct for SNAP, second slot and third slot, IFT examination and ZAT examination. Absolutely, Sadanand, perfect method. Good. Now, Sadanand, I'll save your time. So if you are given directly a factorial, okay, direct factorial given hai, expression is not given in any other form. Direct factorial hai. Now to find out the power of 6, obviously we need to compare the power of 2 and 3, right? Now there is no need to find out the power of 2, just calculate the power of 3. So calculate the power of the larger of these numbers if you are given direct factorial in the question. अगर किसी और टाइप का क्वेश्चन है, किसी और टाइप का एक्सप्रेशन है, then you need to like get into the details. But if you have direct factorial, just calculate the power of the larger of these numbers. Okay, so yes, power of 3 is enough. So 100 factorial, power of 3 कैसे निकालेंगे? I'll divide 100 successively by 3. So 100 upon 3, quotient is 33. Then 33 upon 3, quotient is 11. 11 upon 3, it is 3. Then 3 upon 3 is 1. Just add these numbers and the sum is 48. That will give you the highest power of 3 or highest power of 6 in 100 factorial. So the correct answer for this question should be 48. देवो 2 का पावर क्योंकि ज्यादा आएगा. So if I'll calculate the power of 2, so power of 2 will be 98 and power of 3 will be 48. 97, I'm sorry. 97 आएगा power of 2 and power of 3 48 आएगा. Okay. Now the power of 6 will be decided by the lower of these two powers. So 48. Now obviously 100 factorial में 2 की पावर ज्यादा ही होगी 3 की पावर से, so there is no need to calculate the power of 2 because the answer will be decided by the lower of these two powers. So that is why we did not calculate the power of 2. All right, so the correct answer here is 48. That is option D. All right, okay, so that was the last question for the day. Now one of the students has asked about Euler's theorem, तो मैं थोड़ा सा पीछे जाता हूं and उस क्वेश्चन को ओपन कर लेते हैं. Okay, so this was the question. I need just some empty space, so I'll remove that. So first of all, the statement of Euler's theorem. A upon n, if the power is phi of n means Euler's number of n or any multiple of it, then the remainder will always be 1. हमेशा remainder 1 होगा, provided A and n are coprime. I'll take examples. ठीक है? Now first of all, let us know how to find phi of n or Euler's number of n. So let's say any number is 30. 30 को prime factorization में convert करो, 2 into 3 into 5. Okay, so phi of n, where n is written as a raised to the power p multiplied by b raised to the power q multiplies c raised to the power r and so on. So phi of n can be written as n, that is number, multiplied by 1 minus 1 upon a, 1 minus 1 upon b. ये formula books में मिल जाएंगे आपको, 1 minus 1 upon c. This is how you can calculate the phi of any number. So phi of 30, keep listening to it. Phi of 30 will be 30 bracket 1 minus, so a is 2 here, 1 upon 2, 1 minus 1 upon 3, 1 minus 1 upon 5. Devu, I'll come back to that. Yes, Gaurav, Euler's number of a prime number is always n minus 1, but I'm talking in general what is Euler's number for any composite number as well. So 30 into half into 2 by 3 into 4 by 5. Cancel. 120 upon 15, that is 8. So Euler's number of 30 will come out to be 8. Okay? So if you have any number, any question like this, 17 raised to the power 8 divided by 30. Okay, what will be the remainder? Now one thing that we'll check is, first of all, 17 and 30. A and n should be coprime with respect to each other. So 17 and 30, are they coprime? Yes, they are coprime. So if they are coprime, now I can go ahead and apply Euler's theorem. Now I'll find Euler's number of 30. Euler's number of 30 is 8, which is the power here. So I can directly say that the remainder will be 1. Even if the power is any multiple of 8, then again the remainder will be 1. If the power is 17 raised to the power 81 upon 30, now the power is not a multiple of 8, so power 81 है, 81 में से maximum highest multiple of 8 कौन सा निकाल सकते हैं? 80 remove कर दो, completely भूल जाओ. So 17 raised to the power 1 will be left, divided by 30 and calculate the remainder. Alright, so this is the entire Euler's theorem that I can talk about. Alright, chaliye. So that is all from my side for the day. Okay. Devu is asking another example. So Devu, चल एक और example देख लेते हैं जल्दी से. No harm in spending some more time. So let's say question is 200 factorial and we need to find out the power of 72. चलो देखते हैं कौन सबसे जल्दी आंसर देता है. Okay. Wait, Mandeep. Class is not over yet. So 200 factorial and I need to find out the power of 72. Now 72 is not a prime number. I can write 72 as 3 square into 2 cube. So in 200 factorial, I'll be looking at the power of 3 square and 2 cube. So पहले power of 2 cube करते हैं, तो 2 की power निकालते हैं. So 200 को 2 से successively divide करो. So 100, 50, 25, 12, 6, 3 and 1. Add these numbers: 150, 175, 185, 197. So power of 2 is, so 200 factorial, power of 2 is 197. I'm explaining you. So next is power of 3. So 200 upon 3 is 66, 22, 7, 2, 88, 90, 97. So power of 3 is 97. All right. Now 2 का पावर पता लग गया, अब 2 क्यूब का पावर निकालना है. So power of 2 क्यूब, 2 raised to the power 97 है. So here power of 2 क्यूब कितने मैक्सिमम निकल सकते हैं? It will be 6 and 5. 65 can be the highest power of 2 cube. And 3 square का maximum power कितना निकल सकता है? 3 raised to the power 97 है. So half कर दो power को, 48. So highest power of 2 cube is 65 and highest power of 3 square is 48. So the power of 72 will be 48 in this case. All right. सदानंद 8 की डायरेक्ट पावर नहीं कर सकते because 8 is not a prime number. We can find the powers of prime numbers only using this method. Okay, so that's all friends from my side. So that was one example. CAT 2023, anyone who want to join a program, comprehensive program, complete details are there on your screen. Upcoming session, there is one session tomorrow, 9th of December, understanding the logic behind logical reasoning, part number 2, taken by Naveen sir at 7 p.m. tomorrow. Shyam, your center is Chennai heavy cyclone. I am not sure if the paper will be postponed or not. So sorry, I cannot be sure about this. Okay, because not seen this kind of thing in the past. So I'm good at English, LRDI, but we can quant. Please give me last minute tip. Divya, quant in that case, try to spend only 10 to 15 minutes. Don't spend a lot of time if you're not confident in quant, and try to spend maximum time in the other two sections. All right. So that's all. Please don't forget to join us day after tomorrow, 10th of December at 6 p.m. for the first impression and the detailed analysis of SNAP first lot. That's all friends from my side. Thank you very much. All the very best to all of you for 10th December examination of SNAP. All my wishes are with all of you, and I wish all of you will get some good colleges for your MBA. That's all. Have a good day. Bye-bye.